Welcome to qnawire.
In this question, we are asked to prepare a pH 3.0 buffer. So pH of buffer is 3.00. Starting from 1.2 liters, 1.25 liter of 1.00 molar hydrofluoric acid, and any amount you need of sodium fluoride. Okay, so X sodium fluoride. So what is the pH of the hydrofluoric acid solution prior to adding the sodium fluoride? So the pH of the 1.25 liters of 1.0 molar HF. So 1.00 molar means we have 1.0 mole in 1,000 mil, or 1 liter. Let me put it that way, 1 liter. So therefore we have X mole in 1.25 liters. So that is 1.25 mole, right? So X is 1.25 mole. So the molarity of a solution is of course 1.0 molar, and this solution is hydrofluoric acid solution. So when it's ionized, you have H plus F minus. So if you have 1.0 mole of hydrofluoric acid, let's do it like this. So we have the concentration, we have initial, or we say we have let's do the highs, initial, concentration, and the final concentration. So initially we have we have 1.0 mole. And then we have 0 of this, and then we have 0 of this. So then the concentration will be minus X, will be plus X, and this will be plus X. Then the total will be 1.0 minus X, and this is X, and this is X. So the Ka will be H plus concentration F minus concentration divided by concentration of hydrofluoric acid. And the Ka for HF is 6.3 times 10 raised to power minus 4. And that will be concentration of H plus is X, multiplied by concentration of F minus, which is X, divided by 1.0 minus X. So if we solve for X, so X will give us, it's going to be square. Okay, so X will give us minus 0.0254 and 0.0248. So we're gonna go with this because concentration cannot be negative. Therefore, we can calculate pH since we know the concentration of H plus. So pH is going to be negative logarithm of H plus. And from here, we said that X is H plus and F is H plus. So whatever the X is H plus and X is F minus. So the concentration of H plus and F minus are the same. So we find X to be 0.0248 and minus 0.0254. and we pick 0.0248 because concentration cannot be negative. So that means the concentration of H plus is 0.0248. So that means pH will then be negative logarithm of 0.0248. And that will give us what? 1.606. So this is the pH before adding sodium fluoride. Then B said, how many grams of sodium fluoride should be added to prepare the buffer solution of pH 3.0? So we know the pH is pKa plus logarithm of the fluoride over hydrofluoric acid, or the sodium fluoride, I can put it that way. All right, so the pH we want is 3.0 is equals to the pKa of sodium of the buffer is 3.2 plus logarithm of, we are looking for the concentration of sodium fluoride, we don't know, and concentration of hydrofluoric acid is 1.25 mole, because we explain here that the concentration is 1.0 and 1.0 molar, and that's 1.0 mole in 1 liters, and we have 1.25 liters. So that 1.25 liter will contain 1.25 mole. So since we're trying to determine the amount of the sodium fluoride that needs to be added, we need to know, we need to use the number of mole of the hydrofluoric acid that is present. So if we solve this, go ahead and this will be minus 0.2 is equals to log of x over 1.25, and this will be 0.631 is equals to x over 1.25. Therefore x will be equals to 0.789 mole, and that is the number of mole of sodium fluoride. Because the number of mole of sodium fluoride. Therefore, we can calculate the mass of sodium fluoride by multiplying this number of mole by the molar mass of sodium fluoride. So molar mass of sodium fluoride is 42 grams per mole. Therefore, mass of sodium fluoride will be equals to 42 grams per mole times 0.789 mole, and that will be 33.138 grams of sodium fluoride.